In this series of videos, we will discuss how to do some basic footprints and layouts using the Cadence software package. The first step in creating footprints is making sure you have the correct pad stacks. Now, by default, there are a lot of pad stacks already created in Cadence, but in this video here we will show how to create some footprints. And now footprints, just so you know what they are like, for instance, where the pins will be physically connected to the circuit board. And there's various types of footprints. The most common ones that you will most likely use is either a through pin, and this would be for components that you put through a hole and then solder on the bottom side, or a surface mount pin, an SMD pin, and this would be, again, obviously for surface mounting. There are other pins and holes that we will talk about in some more advanced videos. So let's start with a through pin. So you select it and then you select your pad geometry, and for a through pin the most standard one is circle, although you can select any of these. The next thing you need to do is go to drill, and you need to say, okay, well, it's going to be a circle, and you need to specify the finished diameter. Now, often here our units by default are in mils. Mils is not millimeters, and often a lot of CAD drawing are in millimeters, and it'll say changing to millimeters will result in a loss of accuracy. Continue, and you can go ahead and say yes. So first off, we have to decide what the size of the hole should be. Now this is something that you would see based off of your CAD drawing for your particular component. Now the key thing is if the component pin, for instance, let's say is 0.8 millimeters, you don't want to drill a 0.8 millimeter hole. That doesn't give you any room for any kind of tolerances on the size of those pins. At minimum, you would want to do a 0.9 millimeter hole, and quite frankly, at a 0.8 millimeter pin, you might actually just do a 1.0 millimeter hole. Now, as far as the tolerance, we don't need to worry about this, and it will go ahead and bring up, oh look, there's our circle. Now, secondary drill is something that we won't need to do, but there's options for like back drilling, countersinking, and things of that nature. Those are for some more advanced types of layout applications that are beyond the undergraduate level here. Drill symbol, we need to have a symbol. This is what the symbol will be used when we actually attach it on our footprint. And so the symbol, well, since I'm making a hole that's a circle, I should have my symbol be a circle. And drill figure diameter, we should just make the diameter the same as the actual drill hole that you are making. Drill offset means that if you actually wanted to offset the actual location that you were drilling, so for instance, if you had an offset of 1 millimeter, wherever you're actually telling it to drill, you would drill 1 millimeter to the right. There are reasons to do that. The next thing, though, that's required are what are called the design layers. The design layers, the begin and end layers, you want to think of as the etch layers, like the top and the bottom. So I need to say first, I need to have a regular, I'm going to do a circle. Now, I need to think about this here. If I did 1.0 millimeters for my design, you can see this blue little thing get put on top. And that's actually terrible. That's the amount of copper that would be etched out around the center of your hole. If you're drilling a 1 millimeter hole and you etch out 1 millimeter, you're not going to have enough copper. Well, in fact, there's going to be no copper left to apply solder to. So in general, you want to go bigger than that. How much bigger depends specifically on the actual components that you're using. The larger the diameter, for instance, if we do 2 millimeters here, you can see now we have the blue being shown here. This is actually going to show what copper. So you can imagine this blue will be copper and the red will be the hole that's drilled through the board. Now you might say, well, that's great, but then we also have to be concerned about, well, wait, if you make that place too big, the pins will run into each other when you create your footprint. So that's where you need to refer to your CAD diagram on the size of pin as far as the amount of copper you can have. And when we get into an example doing an actual footprint, we'll go into that in more detail. For now, I'm going to put this down to 1.5. And so I have 1.5 copper. And then we're also going to have an end layer being a circle, and I'm going to do 1.5 as well. And again, you can think of this as being top and the bottom. So on the top of the board and the bottom of the board, it's going to etch out 1.5 millimeters of copper. Now, even if you're doing a one-layer board, we still do this because we're trying to make general footprints or pad stacks for just general purposes. So even if you're doing a one-layer board, the fact that it's saying, oh, etch the top and the bottom is not a big deal because we're just going to etch one side anyway. But in general, you want to have the practice of defining both a top and a bottom layer there so that if we do a two-sided board, that's already been taken care of. Now, the next thing we need to do is a mask layer. The mask layer are for through holes, we want to at least put a solder mask on the top and a solder mask on the bottom. The solder mask is basically, when we get to a finished prototype, it's that green or red, depending on the color, coating that goes on the board. And it goes on the board and covers up all of the traces except where we want to have solder. And this just helps prevent us from making undesired solder bridges. So the typical rule of thumb is to make the solder mask slightly bigger than the actual design layer. So in this case, I'm going to make it 1.6 millimeters. Now, it's not going to show us what that is, but I'm going to put both a solder mask top and a solder mask bottom. All right, and that's essentially all we have to do for this. There is a paste mask top and a paste mask bottom, and that's for if you're doing a surface mount component and you want to actually define where to put the solder paste. But for this one, that is all we need here. So I'm going to go ahead and then just save this, and it says warning, no default internal pads. No internal pads will be added for unmatched pad stack layers or when additional internal connection layers are added to the design. So I'm going to remove that warning by simply, what that's saying is if you can have internal layers as well, and that's for multi-layer boards, and so I'm just going to go ahead and put an internal layer in there just to get rid of that warning. You could save it without it, but if we were to have multi-layer boards, this is how we could have a connection then on an internal layer. All right, so now I'm going to go ahead and save it, and it's going to come up with a name for us to save it here. Now, I've created, and I would recommend that you do this as well, a directory where you contain all of your pad stacks. You should not save it in the actual Cadence directory. I've got mine saved on my Dropbox account in a Cadence directory, and then in a directory I call pad stacks. And then you want to create a name that makes sense to you, recognizing the fact that you're going to have to find this name when you create your footprints. Now, I have my own kind of standard naming convention here. You do not have to follow it. This is not an industry standard. This is my own personal one. And so what did I do? I did a 1 millimeter hole, so I would do 1, and then what is the size of the copper? It's 1.5, so I do 1.5, and then I would say CIR for circle. So then I would go ahead and save that. So then I know that's a 1 millimeter hole, a 1.5 millimeter copper etch around it, and it's a circle. So I will save that. So now I have that pad stack that I can use in Footprints.